Okay, hello everybody. Jim Lynch, going over some TDD, test-driven development things for this DefiSummer presentation. And yeah, I've been really involved with the ETH Global NYC. So we do kind of every Friday, like a test-driven development thing there. And I haven't gone to any other DeFi summer events, so just like background about me, I guess I've been working as a software engineer since maybe 2013 and didn't start doing test-driven development until a couple years in, actually. And it just some of my early days of being a coder, I would just drive home on Friday night like, oh crap, I hope I didn't break everything with that last push that I did. And yeah, over the years, I've just been getting more and more into automated testing and pretty much only work on teams now that do TDD just because, like, if I'm not doing it, it's like not fun and just doesn't work out well long term generally. But so I have some slides here, and then I was thinking we can get into some coding and setting up a project with Truffle, and you guys can just see how I like to code, which is obviously not the only way to do it, but just one way of like getting into Solidity and TDD, and yeah, just something to get you started. So one thing, TDD is not about speed, right? It's about correctness, and your project manager will probably inevitably say like, hey, like, can't we just skip the test now and just like push it out a week earlier, and it's it's a slippery slope because you really want to push code that works, right? Continuously iterating on stuff that works. And having the confidence that when you push something, you're not going to break other things with your commits and deploys. And then, the meta zooming out from more than just you have to be confident that your team's code works. Even the intern that just started last week, you need to be confident that their code works. And when you have the automated tests and everything working together, it just gives you that confidence from every build. And so we're kind of aiming for the shortest possible feedback loops. So when you get this nearly instantaneous test results, it just helps you, right, to know that what's happening in your code, right? If it's working or not working, depending on what you're checking in your tests. And pair programming is just kind of another example of just shortening the feedback loop, right? If you're doing solo work, as we call it, right, where you guys just meet every day for stand-up, and then everyone breaks off, does their own thing, and then there's pull requests, and the reviewer has to get into the context of what you're thinking, and there's like back and forth. Where pair programming, all that just happens, right there on the spot when the code's being written. And okay, my order of my bullet points is not right, but whatever. Frequent interaction of the developers and like the end users. I feel like the more that happens and the more frequently it happens, it's just it ends up in building a better product sooner. And you want to be frequently deploying things through your pipelines, right? Have pipelines that are running those automated tests. That's one of the advantages of your automated tests, is that they're automated so that they can run in your build servers and in your different environments, dev and staging and prod. Okay. Another thing when you're testing to think about is mocks and spies. So keep in mind your function under test, right? And if you're testing function foo in in your test for foo, you're going to be testing the implementation of that. But when you're testing another file that uses foo, then you probably want to spy on that, return a fake. I think I have a bullet. Okay, my bullets are all over the place, but right. So this is what I'm trying to say. If you're testing function A that imports another file B and calls the function foo from B, you generally want to mock that return value of foo and do some kind of assertion that's expecting foo to be called with the right things, right? So when you're importing things or reaching outside the file, you generally want to mock those things. There is something, I forget if I added a slide for that, but there's this phrase, don't mock what you don't own. And just like as an example, we were doing a JavaScript Node.js project, and we were doing a lot of Mongo code that interacts with Mongo and uses the Mongo library, find one, and things like that. And in our, CRUD service, we could have said spy on mongo.find1. But that kind of leaves you open to, right, if the authors of the Mongo library decide to change that function, it's not called find one, it's called find single or whatever, then your tests break, right? Because you're mocking this function that's now no longer there and it's not doing the right thing. And so instead, we decided to use this library called memory Mongo server, something that kind of runs against an in-memory version of it, so that we didn't have to mock that library that we didn't own. We could just kind of let it call through and then expect that the right things were in the database, and it was nicer that way. Okay. So code coverage is another thing that comes up, right, when you talk about unit testing and TDD. And it's funny because I like to just say that it's a tool for telling you where you're missing tests, And I like to, when I have all green hundreds across the board, take a screenshot of it and say, like, yeah, I'm the master of testing, everything's amazing. But actually, there's like having all green hundreds doesn't necessarily tell you that you have perfect unit tests, right? It actually doesn't say anything about your assertions. You could write tests that call all the functions, every line, every if statement, and not do any not expect anything to happen. And all your tests will pass and they'll never fail because there's no assertions in it, right? But your code coverage is not going to flag that at all. But the useful thing about code coverage reports is that you can see, right, if you have an uncovered line or uncovered branch in your logic, then it's like, okay, well, there's clearly not a test covering this. So I can try to come up with a test where the code execution goes through that piece, right? And then use your general rules of thumb of what are good assertions for just expecting that the right thing should happen. Okay, so then there's kind of the difference between unit testing and end-to-end testing, right? And I like to say that both are good to have and they serve different purposes, kind of, End-to-end testing, I would say, gives you a lot of confidence that your things are actually working fully. From a user perspective, you can run end-to-end tests against your live environments and see that they're returning the right thing or working properly, and so that's good, right? Um, but a lot of times when end-to-end tests fail, they just kind of like shrug and say, I don't know, it didn't work, where your unit tests are a lot more granular in the functions, saying you expected this, but it was actually this. And those can be a lot easier for finding, a lot better for telling you where the root cause of the problem is in terms of your code. And right, so end-to-end testing can vary widely. If you're working on an Angular project or React, a lot of times it's like browser automation type of tests, protractor or WebDriver. And if you're um, if you're working on a Node.js project or backend REST API, your end-to-end tests are a lot of times just calling, hitting your different endpoints and expecting them to return the right thing, right? Maybe hitting them with different authentication tokens or no token or things like that. And the solidity test smart contracts sort of straddle the line a little bit between unit testing and end-to-end testing because you're kind of can see some of the blockchain there in your tests, how you have the accounts and different things that you can call into the blockchain and see things. And right, you still want the unit test because they check all the different corners of your individual functions. They give you a lot of details about what failed. Okay, so this slide kind of similar to the joke. This is incorrect categorization, saying that every type of development is kind of a form of test-driven development, right? And there's different types, right? So there's automated test-first development, right? And this is what most of the people who are telling you to do TDD, this is what they're saying, where you write the failing unit test before the actual source code. Okay. And this is really the most efficient way to write your tests that validate something, and then the source code that does that thing, because then, right, you want to keep the moving parts to a minimum, right? So you have a project that works, and then you write a test, and that test fails. And then when you write some code to make it pass, you can say, okay, well, now that test is passing because of the code that I wrote. And that connection there is nice because then you can be sure that, okay, that code that I wrote is what makes it pass. It's not just an always passing test. And so this is a different form, automated test after development, right? And this is when your boss is like, okay, well, we need to deploy this in like 3 days from now, so we don't want to write any tests. Just hack it together and let's deploy it, and then we'll write some tests later. Okay, so then you do that, and now you come back next week, and you're like, okay, because we want to have these for long term, let's write some tests now. And I say here, it's not really as efficient because now you need to go back into each file, get back into the context of like, okay, what was I thinking when I wrote this file? What does it need to do? What are all the different edge cases? And it's, a lot easier to do back when you're initially writing. And also, you need to verify that your tests are not incorrectly passing, right? So everything works in your system. Now you're writing tests, and because your system works, your test should pass, right? But how do you know if your tests are passing because the system works or because they just always pass? How do you know that your tests fail when they should fail? And if you're doing it this way, then you end up going back and like breaking pieces of your source code and seeing that your tests fail, and that's what gives you the confidence, and it's just not as efficient because you keep going back and forth in this way of checking that things fail when they should fail, when really they were initially failing before you wrote the source code, so that's a good time to check those things. Okay, and then there's the final way, right? This is manual tests after development, and this is just a person, running it locally, poking the system, and then you visually seeing what happens and saying, did it work correctly, did it not, And yeah, this is just what everyone starts out with, right? If you're not writing automated tests, you're probably doing that, right? Because how do you even know if you're doing anything correctly? You run it and then you use it and you see if it works. And, that's fine, honestly, especially in the beginning, or if you have never used a library before, you do a spike project over here without tests and just try things, experiment, and see what happens. But it's just hard to scale that. And I have this fancy, very scientific diagram where the y-axis here is how expensive, difficult, time-consuming it is to add a new feature. And this x-axis is the size of your code base, right? And without automated tests, it's really easy to get started and just write some code and have a thing on the page, and you're like, yeah, we're doing stuff. And you kind of find that as your code base grows and grows, it becomes harder to maintain things, and bugs start coming up, and you become like afraid to change things because bugs happen, and when people do that, and then things get out of date, and it's just like all these compounding things where it gets exponentially harder just to develop any new thing. And with automated tests, it's much easier, right? Like as your code base grows, there's still a little bit of like it's not totally rainbows and unicorns, right? You'll have because your tests break, you need to you go from one working iteration to a new working iteration where things are supposed to work differently, and so you do need to break some tests and change things around and fix things. And as your code base grows, there's just more stuff to maintain. But it's definitely a lot more manageable when you have automated tests. And because you can just kind of flip a switch and say, do all my tests pass or not pass? You can do that for a lot of code, and just having that instant feedback is really useful. Okay, so because we're doing blockchain, DeFi stuff, I want to talk about Solidity specific testing things. Asserting that a contract reverts when it should, right? Reverting is not really a thing in a lot of other platforms. So, but it's kind of similar to expecting that error was thrown or promise rejected. And hoping we can get into that in the code in a little bit. the accounts, right? So there's accounts injected into your tests, and those are actual Ethereum addresses, accounts for you to use. So there's Web3, just some other different things, objects in the global scope there that you can use just to be aware of. And so these are some good TDD books. They're pretty old, right? Kent Beck, R. Fowler are sort of like the original pioneers of TDD, so they'll probably be talking about Java and all these old things, but there are definitely good books just to get into like the philosophy of thinking about coding TDD style. And some other good resources, Crypto Zombies was honestly the way that I first dipped my toes into Solidity coding. I think that's a pretty nice app. Browser way of learning. And they do have, there's like 6 modules of just this is the syntax of Solidity. And then they have a whole little series on Truffle and testing. So that's pretty good. And then Exorcism.io is just pretty much everyone that codes or is getting into it or is advanced or anything. I recommend Exorcism.io. It's a website for kind of just practicing exercises, and they have like the challenge, what you need it to do, and then they have all of these pre-written unit tests, and you're supposed to go through and they're commented out in the beginning. You go through and bring them back, right, and have them actually running, and you work through them, and then get everything passing, and then you can submit your code, right? So even when you have everything passing, then you submit your code, and the mentors, they call them, just kind of volunteers who will come through and critique your code. And so it's just a really nice way of learning, and getting better faster, because they just give you other things that you would like never otherwise think of, like, oh, this way of converting to a string totally works, but did you know in this case this one is actually 60% faster, and just weird things like that. So yeah, definitely check out these 2 resources, both totally free, so that's cool. And so one final thing is Truffle. Not the only way to do blockchain coding, but definitely one good way. So you just install it, Truffle, and then Truffle init to start your project. And I think that's all for my slides. So yeah, I did create just this empty repository here. So just gonna clone this. So is my hackathon project for that Hack Money Hackathon. And I'm just gonna make a new folder here. Not sure if you guys can see that. Maybe I'll make it bigger. Okay, so there's nothing in here. I'm gonna clone this repository so that people can come see this later. Okay, I'm gonna do nvm use 14, Node.js 14, just because that's what I already have Truffle installed with. And I'm just going to type Truffle just to check that I have installed. That should show me the possible commands here. So it does. And I want to do this one. Initialize the new empty Ethereum project. Okay, and it's successful. So we can see there's all these new files here. I like to do, right, they actually don't give you any package JSON. So I like to just say npm init, make a package JSON. Just keep hitting enter because it doesn't really matter. And so another thing I'm going to install, and I'm going to say is truffle assertions. Okay, and this is just something that helps with testing the revert when something reverts. And I'm going to do -d for the save dev, putting it in the save dev spot on our package JSON, which doesn't matter a whole lot since we're not like packaging this and deploying it with npm, but whatever. Okay, so I need to install this, install code, command, and path. And now when I do code here, it will open VS Code. And so we just have this empty migrations contract, this migration file, and package JSON with our truffle assertions here. And another thing I like to do is nodemon or nodemon, however you say it. So this one, because there's not really a truffle watch mode per se, I've been using nodemon for this. Okay, so test just echoes an error, which is not super useful. So I'm going to make this truffle test. Okay. And we don't have any tests here. So, right, I was thinking just as like a relatively simple contract, we could do like magic number. So there's a number that we save into the blockchain, and the contract owner can change it, and other people can just read it. Okay? So first I'm going to say truffle create, and that will create our contract. And if I go up to the commands here, so truffle create is a helper to create contracts, migrations, and tests. And do we kind of want all three of those? So as a shortcut, you can say all, truffle create all, and I'll just call this magic number. Okay, so then if I check back here, I have an empty contract, magic number. I have this migration file, which is actually a little too empty. We kind of want this. So I'm just going to do Control D and select everything and change this to magic number. Okay. And then we have this test here that just checks that it gets deployed, basically. Okay. So I changed my package JSON to run truffle. So if I say npm test, Okay, so it compiled the contract, deployed it, and our magic number was deployed, so that's good. So, and yeah, definitely when you're doing TDD, right, the short feedback loops, you want to be able to run something in watch mode. So I'll just call this watch. Nodemon. And then ext is the extensions. And so here I'm writing my test in JavaScript and the source code in Solidity. So we want to say both JS and Sol files. And then --exec for what command you want to execute when something changes. Okay. Okay, so now we can just run that and it should keep running when we change things. Definitely is not as, lightning fast as I would like it to be, but so if I just do this, hit save, then you can see it's starting a new test. So that's pretty cool. And, okay, so I'm going to say, remember we can have describes full of its. So I'm going to say describe this magic number. And let's just say we want it to be, I like to have these both kind of open at the same time. So I'm going to open the magic number Solidity file contract up here, and then the test down here. Just close this because it's not really that useful right now. So what I want to do is kind of say, uint public equals 42, right? And, oh, I need a name for this, right? So I'll call this magic num. And so really, right, it's easy to just dive in and start coding. But remember, we don't really want to write this yet. We first want to write a test that will fail and then pass when we write this on line 6 here. So another thing to think about just in general when you're writing tests, so this kind of triple A order of doing things. And so the first one is act, where you the first one is arrange, okay? You arrange everything into the proper places, mock things, and, set it up. And then act is kind of calling your function under test. You set everything up, do the thing that you're testing, and then expect everything to have happened correctly. And that expecting everything to have happened is the last assert part. So for this one, okay, so this is another thing. We're importing our contract and saying .deployed. That's something that we're kind of going to want to do in every test, pretty much, use the contract. So sometimes I'll just put this in a before each up here. And because we have await here, we need this to be async. And I like to even set this to a variable contract. And we're just going to reassign it every time. to that deployed. This is another thing that actually tripped me up in the beginning, is that deployed returns the same deployed instance of your contract across every test. And you have to do new if you actually want a new fresh instance of your contract in each test. So a little bit slower, but it will automatically, reset everything. Okay. So I wrote these out, and of course you're going to want them in an it, not just in a describe block like this. So I'll say, so we're describing the magic number, it defaults to 42. Okay. And so there's not really a range that happens here. The act, we're really just reading the number. So I'll call this actual num. And okay, so I'm gonna do this not totally correctly, but we'll just say dot magic num. Okay. And then we want to basically expect that this actual number, expect it to equal 42. Okay, and this should not pass because we don't have anything here. Okay, so expected undefined to equal 42. So if I console log this, what is magic num? And we don't have anything here, so obviously that would be undefined. And so if I now add this source code, okay, so we can see that the thing that we got here, so it's a little bit tricky to read this sometimes. This is the log that we had here, logging out contract.magicnum. And it looks like it's a function, right? So we have this function and a few different things on it. So the key here is that you want to actually call this, and I think this will say that it's a promise now. Okay. Sorry. I meant to do this. And I've made this variable, so I might as well use it here. Okay. Yeah, and so these are kind of functions of a promise. So I'm going to say await this and make this function around it async. Okay, so we're getting closer. And we see this weird thing, BN brackets 2A, and what it's basically saying is that this is a big number, right? Because we're dealing with way in the Ethereum world, and it's like massive numbers. We pretty much always dealing with big numbers in the Web3 library. So you can either convert 42 to a big number, or maybe a little bit easier would be to just stringify this. So we can say dot toString. So we're pretty close now. We're saying that expected this string 42 to be the number 42. Okay, so this, put a plus sign in front of it is kind of a very terse way of just converting something to a number in JavaScript. So I think this should pass for us. Cool. Okay. So we're able to get this magic number, and we made it public so we can read it from our file. But let's say we wanted to, let's say we wanted this to be private. And we want all the users to be able to read this magic number. Okay. So our test now is failing because magic number is not a function, right? We've made this private, and so our test can't read it. So I guess we would expect that. But we need to be able to get the number somehow. So I'm going to say current num, and I'm going to call a function on this contract, right? And that's kind of what you're, in TDD, you're deciding on the new things, naming your new functions before you even have them in your contract here, which is kind of a weird feeling at first, but yeah, it works out. So I'm going to call this function what? Get magic num. Okay. And so I didn't talk about this either, the accounts. So you can uncomment this. This comment here talks about the accounts a little bit, and you can go to this webpage to learn some stuff about it. But the key thing to know is that accounts is a list of strings that are the addresses. So if I log account 0, and so the 0 one is the owner, the contract owner, right? The account that deployed the contract, and the other ones are just other users that are calling to it. Okay, so here, just wanted to log out these things. And these are just different wallet public addresses of your test wallets that it's using for these test runs. Okay, so if we call this from, by default, it'll be calling it from the account 0, which is the owner. And some people even like to destructure these, right? So I can call this one owner, user 1, user 2. And I can say from owner. And I could say from user 1, from user 2. And I'll just maybe just add these onto the end of my variables here. So these are the current num as seen by these different people. And we basically want them all to see that the current number is 42. Okay. So user 1 and user 2. And so it should be saying counts is not defined. That's not right. So where is it using accounts here? Okay. So I renamed these. It's not a thing anymore. But we could easily just say console log owner user 1 and it would print the same addresses. Okay, so get magic and num is not a function because we didn't create it yet. Okay. Function. And we are not calling it with any arguments. This is just something you can kind of add into your function calls on your contract. So you would say, right, arg1, arg2, and then just comma, and then this object of who you want to call your function from. But for this function, we don't need any arguments. And it'll be public so that we can call it from the test from the outside. And it'll be a view because we're just returning something from the blockchain. And it'll return this uint. Okay. Okay, so we're getting this weird thing where it's trying to compare a big number and just a regular number. And there's different ways you can do this, right? You can do Web3 to BN. And with the chai mashers, you can say 2.bignumber.equal. But I think for now, I'm just going to say 2. Let's just highlight these. And I'll just do a .to string on these. And remember, we also want to convert it back to a number, so. Cool. Okay. So we're passing. So we have this. Then I wanted to say changing the number. Okay, so we have this describe defaults to 42. And remember, you can have nested describes. Describe, full describe. So I can say defaults. You know, maybe arguably just an unnecessary thing, but it's fine. Okay. Constantly just doing Alt-Shift-F to reformat, just so things look nice and pretty aligned. So I have this described for the default. Don't really like everything just without, you know, like multiple empty spaces is like a linting error, but to me, one empty line is just, you know, make things a lot easier to read sometimes. So I have this described for the defaults, and now I want to make it described for like changing the magic number. Okay. And I'll say it can be changed by the owner. Okay. And so here we have kind of the act. Arrange. Okay. So in the arrange, I want to set it. I want to set it by the owner. Set it from async. And I'm going to say change magic num. Okay. And remember, it gets called by default from the owner, so it's kind of unnecessary to say this, but this should still work too. Assuming we have this function, right? Which we don't right now. But the idea is that I'm going to call this and possibly, I don't know, you could say maybe this getting the num. Is this the act step? Is this still the arrange step? I don't know, but it doesn't matter that much because we're just going to delete these. And so anyone should be able to read the magic number, so it doesn't matter a whole lot who we do this from. And changing the magic number, I think we are going to want an argument because we need to tell it what to change it to, right? So I'm just going to set this to a constant, and I'll say new num equals 100. Okay, we're going to pass that in here, and then do our same expect kind of thing, converting it to a regular number, and that will be our assertion that the current num that user 1 sees is our new number. Okay. And did our tests stop running here? Okay, they're there. Okay, so it's telling us that we need to make this function. That's fair. So this will be a uint, and I guess I'll just call this new num. Okay. And really, we're just going to say the magic num, set this to be the new num that we pass in. Right? And it works. So that's doing this. Change it from the owner. Okay, so now remember I said that we want this change magic num to be kind of an admin function, right? We only want the contract owner to be able to call it. And this is just like a super common thing with blockchain development and smart contracts, that you have different roles, right? The owner is able to pull ether out of the contract or assign other addresses to certain roles, or, whatever. But you want to write tests to say when certain users call this function, it responds properly. So I'm going to say, right, this is still in the describe, changing the magic number. So I'll say it does not allow non-owners to change the number, to change the magic number. Okay. And a lot of this is going to be the same. New num, I kind of want to bring down here, copy and bring down here. And because it's just a constant, I'm thinking maybe we could just bring this all the way up to the top, define it here maybe. And then we can just use it. Okay, so here we want to call this change magic num from a bad user, let's say from user 1, and we're expecting it to revert. Okay, so how do we do that? And that comes back to, remember in the beginning we installed this truffle assertions. So I'm gonna say const truffle assert. This, if you're looking at the docs, they have like an example and they pretty much do it like this. And then require truffle assertions. Okay, and they're calling that truffle assert. And then we want to say truffle assert dot reverts. See this first thing that it's suggesting here. And you pass in the whole promise of this function call. Okay, so let's try this. Expect that when we call this from user 1, that it reverts. Okay, and remember we don't, this is, okay, so we forgot to put async on something. Looks like this one. Okay, so this is interesting, right? We get this failed test that says assertion error did not fail, So we're expecting the function to fail, and it didn't. And if you have been doing Solidity for a while, you'll probably have come across modifiers. Cool thing that people like to use, and actually in the migrations file, when you initialize a new Truffle project, they give you this modifier here, or they write it for you. They write it for this migrations contract at least. And you can, you could import this, you could use the Open Zeppelin ownable or other things, but I'm just going to copy it over to here for now. And so we don't have this owner variable. And if we look here, this is kind of a nice shorthand way of assigning the owner, right? Because message.sender, when this contract is very first created, is the owner. And our restricted modifier, we're saying only the owner require that the sender of this message, the caller of the function here, is the owner. And if it's not the owner, then we're going to revert with this message. Okay. So if I add this to the function that we want to be only owner, and it passes. And so, yeah, at this point we could come in, right, maybe refactor, change some things, make sure that all our tests pass, clean up our tests a little. Right, some people would maybe like these, now that we're done writing it, just crunch them all together, but that's up to you. Yep. And to add this package lock, package JSON. So yeah, now I'm just adding everything. Push this up to Git so you guys can check it out later if you want to. But I know it's earlier. That's kind of all I had planned. Yeah, went through it pretty fast, but anybody have questions or?
Yeah, I got a question. How do you get coverage?
Mm-hmm.
Do you get coverage on truffle tests?
There is, yeah, Solidity coverage, I think it's called. You need to install another package, and I forget exactly how to do that, but yeah, you definitely can get code coverage on your Solidity code.
Like how long does that usually to develop all the tests beforehand, like with TDD? And like how do you even begin so you so explain like how you design your contracts originally, like okay, how long that process takes. And yeah, so because a lot of us are like some people kind of like code, so it's like how do you know your full test suite?
Yeah, and I mean, how long it takes, it kind of depends. It depends on the project, right? How complicated it is, how familiar or similar it is to things you've done before, and then yeah, just how much experience the developers have with it, and have they done similar things like that before, or getting to the whole truffle assertions thing and expecting things to revert. Like at first, it was like a huge question mark for me, right? I was like, is this like, how do I even test this kind of thing? I had no idea, and then you start Googling things, asking other people how to do it, and it it gets easier, and just the overall like philosophy of like thinking about it. Okay, this is where I want to get to in the end, and then kind of working backwards to building out the functions. I think is like something that's a general thing that you can you can kind of do for any test that you're trying to think of.
So say a lot of people don't really they don't really make contracts from scratch. A lot of people fork. Like say I'm forking Pancake Swap. Like where do I find their test suites, or like or do they normally have test suites, or and like yeah, and like where's like kind of the easiest the find test cases?
Mm, I mean, I wouldn't really recommend forking a project and just going with that, right? Because then you're just inheriting their whole code base, right? If they make changes or bug fixes or whatever, you're not getting them. You broke off and did your own thing. Um, you could like uh, use Open Zeppelin maybe, right? Or inherit from their contracts might be a better thing where you say like this is ownable, right? Something like that. And this you could import from Open Zeppelin or somewhere. Um, but yeah.
Like there's like a culture, and like especially DeFi right now, to like fork Uni, fork Pancake, fork whoever got the feature, let's just take it off that, and there's not much involved in that. So it's like
Mm-hmm. Yeah. I mean, if you're not ever planning to change the code base, then it doesn't really matter, right? But then it's kind of like a dead project from the beginning, unless you plan to just fork their code base every time they make an update, just refork it and redeploy that.
I mean like
But,
like functionality, and then build upon their test suite. Like, do they commonly like release their projects, or like where on that?
mm, some of them are, right? Uniswap and honestly, a lot of them are, right? Because the whole there's like a uh just a thing that people like is for it to be open, right? And because it's immutable and public and on the blockchain, everyone can see what it is. Everyone can see the code for it. And that's partly what makes you trust it, right? Because you know that it's out there. They're not just wiring half of it to their other address, right? Um, but yeah, there are. People will just take the code base and deploy it on Binance Network or something else, right? And I guess they can do that technically, but it's like, yeah, it seems like a huge maintenance headache to me, right? Because now you have this huge code base that no one on your team understands. It's like kind of in the hands of some other team, and yeah, It's like you didn't write it, you know. So is it even your application? I don't know.
Another, because you mentioned like pair programming is a good way to get a feedback loop and like talking about like the East Global NYC builder. So like, do you have any like other kind of like dev groups or like uh, people that are that help you learn this and keep up to date?
Definitely the ETH builders. I'm in like a bunch of different Slack groups, and so I'm in this crypto devs. This one is the ETH builders NYC. This Hacker Hours is a pretty good one. Um, this one is just more than just blockchain stuff. It's kind of everything coding related, a lot of like JavaScript and Python people, but um, yeah, I've been part of this one for a while, and we're hoping to get like a place in New York City in the next couple months or years as like like a chill hangout place to have meetups and do things. So that's cool.
Well, that's actually dope. I just got added to East Builders NYC and Crypto Dev.
Mm-hmm.
So I'm definitely gonna check. Yeah.
Yeah, yeah. And then just like hackathons, right? I was recently on a team, just a couple people from the ETH Builders NYC for this Hack Money hackathon. And there were just like tons of sponsors, tons of teams doing it, and other people, asking to be on a team or just want to talk about their project on the Discord. And yeah, just another cool way to like meet other blockchain developers. And before, like while we were working on this, there were 3 other hackathons that started, and I was, this is too much for me, But there's just constantly uh, new things happening. So,
Awesome. Yeah. Thank you for sharing. And yeah,
mm-hmm.
definitely learned a lot about truffle. So thank you for that. Um, anything else you'd like to add before we go?
um, pretty much that's it. If you guys want to hit me up on Twitter, Lynch Codes, probably the easiest way to reach me. So yeah, if you have other suggestions or ideas or questions, always interested in talking about coding stuff.
Awesome.
Cool. Thanks, James.
Mm-hmm. Yeah, thanks a lot. Thanks everybody for coming and other